Alrighty, folks. Good morning. Today we are starting our wonderful journey into the world of rocks. And no, I'm not going to say all those corny things, geology rocks and this rocks and that rocks. I might have a few corny jokes here or there, but I try not to use those two. It's a natural progression, of course, coming off of minerals, because as you'll see soon, most rocks are made of minerals. And we pointed that out to you a handful of times along the journey already, so it should not be too big of a surprise. And I know you guys have had the rock cycle before at some point in your life. Maybe we have a new twist or two on it here. I'm not so sure. What we're going to set out to do here is talk about the three types of rocks, the way they're made, and more so how they're related, how they're connected. All right, and really show you that we have, going all the way back to when we talked about thermodynamics. Okay. That we have all the stuff we're ever going to have, and in order for this whole crazy thing to be going on for 4.5 billion years, we've been working through the same materials, over and over and over again. So we're going to show you how that all is connected. Unfortunately, for lack of a better word, for you guys, what this means is you've got one more writing thing on a test. We told you on day one, the tests are mostly circling A's and B's and C's and so on and so forth. And while that remains true, we had the definition of a mineral not too long ago. Well, now we have the definition of a rock, and you will be required to write it down. This one also has 4 components to it. And ways back when, in geology, these used to show up on the same test, minerals and rocks. Things have changed over the years. So I strive to make the definitions different to help you remember them. And in retrospect, I don't know if that was so necessary. Now, in earth science, we teach these, they do show up on the same test. That might be a better population of students to ask whether or not, they prefer the definitions to be different or not. I'll show you what I mean here in a moment. But so it's similar to definition of a mineral. It has some obviously key changes that differentiate a rock from a mineral. But I'm referring more to the verbiage. I purposely chose different words. So naturally formed. Well, we could have started out exactly like, we did with minerals, naturally occurring. I don't care which way you remember it. If you already got, minerals down in your head, feel free to start the definition of rock with naturally occurring. It's totally fine by me. Inorganic and here's the big difference, organic. There are some organic rocks out there, okay? There are some. You'll see them in lab class. Consolidated aggregate, and comprised of grains of one or more minerals and or organic material. That one kind of almost seems repetitive. This one I think plays off better as a sentence. But again, however you remember things better, bulleted lists or sentences, I just need to see those handful of words. Naturally occurring consolidated aggregate of organic material and or inorganic mineral grains and rock fragments. That's the definition as a sentence. Same words, just arranged slightly differently. So, we're looking for those components. And again, at least in geology, you will be required to write that down. I think in earth science, when I use this for you guys, later in the semester. I think you just have to recognize it as multiple guess. We'll see. So again, the big difference here is that organic component. All right, and everyone knows an organic rock. You've known one for the last 20 years of your life, coal, okay? Now, I know coal, conversationally, sometimes gets called a mineral resource. And that, again, is just, mixing things up with the mining industry and politicians using words and so on and so forth. Coal is, will somebody tell me out there, where did coal come from? Why do we have coal? Ancient what? Swamps, yeah. Coal is old plant material. And be it a swamp, which is usually what we say, or even a marsh. Marshes provide plenty of green stuff. All right. That is where coal came from. And that's also why coal is not so great for us. And I'm not even talking about the CO2. I'm talking about all the other nastiness that's in coal. If you've ever had a fish tank or taken care of a fish tank and you stirred up the gravel in the bottom, all that nastiness that comes bubbling up and smells oh so great, all right, all of that is in the coal, all right, including, again, if you've had this and this, I'm not saying, go to a pet store and ask them to stir up a fish tank for you, but if you've not done this, I apologize, you're missing a huge olfactory gap here. There is a really sulfury, funky smell that comes up, okay, and that's from all the fish poop and the decaying plant matter and so on and so forth. All of that is in coal, and that's another reason why coal isn't so great. Now, don't get me wrong. You're not going to power Manhattan on windmills and solar panels. At least not for, I'm not coal bashing. I'm just explaining why, it's not so great for the environment. It's wonderful for power. But so it's going to be a long time, unfortunately, before we can say goodbye completely to coal. All right, anywho, sidetrack a little bit there, but we'll get to it at some point when we get to sedimentary rocks anyhow. So, consolidated aggregate, that just means bringing a whole bunch of stuff together. Consolidate means consolidate. An aggregate is a group of things. And so we're defining that in the next bullet there. Grains of one or more minerals and grains of organic material. Sometimes you get a mixture of both. I don't think you're ever going to find something that is straight up 100%, organic material. There's always going to be a little bit of, just because of weathering and erosion, and there's going to be silt and clay and stuff in it. But we call them organic rocks because the majority, you'll see that clincher here. Anywho, so that's the definition of a rock. 3 types of rocks. Hopefully you walked in the door knowing this one, or at least when you see this, you're like, oh, yeah, I remember. All right, igneous, sedimentary, and metamorphic. I really kind of thought I made a little slide for each of these here. Apparently I did not. So we're just going to take a moment and preview, all right, what we're looking at. So igneous rocks are rocks that formed out of lava or magma. They cool and they crystallize. The majority of them form inside the earth, but sometimes volcanoes, right? Sometimes they form at the surface of the earth as well. Sedimentary rocks. Sedimentary rocks are a lot like the chicken McNuggets of the rock world. They're a bunch of pieces, parts of different things thrown together and glued together, presented to you as a new rock. All right, sedimentary rocks are what we have all over the surface. They're a product of weathering and erosion, which breaks down, moves stuff around, and then over time they get squeezed back together and made into a new rock. And then lastly, we have the metamorphic rocks. Metamorphic rocks, as the name implies, metamorphosis. They've been changed. All right. These are rocks that are exposed to very, very high heats and pressures. And those heats and pressures do a handful of changes to said rocks, changing them from shale to slate or limestone to marble, and so on and so forth. We'll Again, we'll get there. Now in geology, of course, we have the full-on lab component of this. You guys are going to have your rock test. And we're going to go in depth into each of the 3 types of rocks. In earth science, for you folks, we really just sort of have a cursory glimpse at these things. We look at a handful of rocks in lab, and then we jump right to volcanoes. So that is one of the big things that distinguishes the geology here on campus from earth science online. So again, the rock cycle explains how rocks are created and destroyed, shows the origins of the processes that are responsible for that, and they show us that essentially Mother Nature was the first recycler. Just rock material is recycled over and over again. Now, we're going to draw this picture, but we're going to draw it a little bit at a time. So please don't, I know a lot of you guys just like copy down the slide while I'm talking, which is, it's up to you. But don't do it in this case, because we're not putting all this down on your sheets. And we're going to talk about it as we draw it. So right now, I really want you just to draw. You've got half a sheet of paper on this one. All right. You're going to want to just draw the 5 rectangles in the circle there. Okay, the rectangles, don't label them even, just draw them. The one that says igneous rock, the one that says sedimentary rock, metamorphic rock, and magma. All right, and to use a clock analogy, for lack of a better word, you're going to want to make one of those rectangles at 11 o'clock, 1 o'clock, 3 o'clock, 6 o'clock, and 9 o'clock. So I'll give you a second to do that. A couple seconds to do that. So we got 5 rectangles. Beautiful. All right. So we're going to start at 11 o'clock there. It is a circle. It is a cycle. There is no beginning. There is no end. But there is a fairly logical place to start. And actually, it's not igneous rock. I lied. We're going to start at magma. Sorry, one step down. We're going to start at magma there. And I want you to also write the word lava next to it. Magma or lava. Just to remind you. Everyone knows what lava is. Mainly this semester you'll be learning what magma is if you don't already know. But we want you to remember that igneous rock can come from both. And you can even write the word igneous rock in that square up there as well. That arrow, however, that arrow is not incredibly useful. What do you think solidification means? Not a hard word there. Huh? Well, that's certainly what happens. I'm not sure that solidification is implied. If that's implied in that word, that just means make solid, right? We're going to say cooling. We're going to say that exactly. But I just think solidification is a really generic word. It means, make solid. Okay, great. How do we make solid? Well, we cool off. And while we're cooling off, we grow crystals. So what we want to write in here is cool and crystallize. Something like that, okay? Something way more useful than just the word solidification. So magma, what you're going to see then is this ends up reading like a sentence when we're done. Magma or lava cools and crystallizes into igneous rock. All right, the next arrow leads us to the rectangle for sediment, and you could write the word sediment in there. And in fact, you could even write weathering and erosion, but off to the side, we're going to take a moment to remind you for now what weathering and erosion means. I don't say unfortunately, but unfortunately, we're going to have a whole chapter on weathering and erosion at some point, fairly soon. So we'll get really into the details. But for now, we just want a little bit of a placeholder here. All right. What's weathering? Someone remind us what weathering is. There's complicated definitions and there's simple definitions.
Breaking down.
Yeah, breaking down. All right. Well, then what's erosion?
Being broken down by water.
Broken down by water. What do I hear in the back? The wearing down. Okay. The water is important. The wind and the water is important, but it's not breaking down anymore. That's weathering, and this is something that I've always.
Being smooth.
Yeah, smoothing comes too. That's rounding, and we will definitely talk about that. But still, that's not erosion. And we've got that. I blame it on this commercial. They might not even show this commercial anymore. I think it was for a heartburn medicine, and it shows that profile of a guy, and his head's turned to the side, and they've got this wonderful red line that comes up, and it was supposed to represent esophageal erosion or something like that. Basically, the heartburn eating out their esophagus, and then they show their medicine going down, and that red line goes away. It was just another misuse of erosion. Erosion, well, again, reminds, weathering was breaking down. Erosion is transportation. Just right now, two simple definitions. Okay? Now, what you said is true. Weathering happens during erosion, and it smooths things, it breaks off the sharp edges, it rounds them, it does everything you guys are saying, but they are two separate processes, and somewhere along the line, we've blended them. It's, I don't say it's bad enough, but already we say weathering and erosion, right? But they are two separate processes. So weathering is the breaking down. Erosion is the transportation of those broken down materials. And as I said, most certainly more weathering happens during erosion. All right, so I don't want to belabor it. Like I said, we do have an entire chapter about it. But again, one more time, just for the record, weathering is breaking down, erosion is transportation of those broken down materials. Hi there.
Hi. He has a paper that says, is there going to be a defensive driving course in here?
Not right now. I'm teaching geology in here until at least, 9:15 or so?
Okay, it's here.
But this is the room.
Yeah.
This is
Does
the
it
room.
say AB on the?
Yeah, it did. It said it.
Okay.
Yeah.
So,
Let me see.
Hold on, let me hit pause on my recorder here. One
Yeah.
second. Come on in. Recording? It didn't do the countdown. Yeah, we're recording again. Okay. I forget what the hell I was saying. So, weathering erosion produces sediment. So, for that igneous rock to be exposed to weathering erosion, it has to work its way to the surface. All right? And that's something we're going to see here in a little while. I'm going to talk about drawing a dashed line through all of this that separates surface processes from subsurface processes. So, anyhow, so now we've got a pile of dirt. And my old office mate was the environmental science teacher here, and he passed away a while ago. He always used to yell at me. He says, "Dirt's what you sweep off your rug. Sediment." All right, man. So, but you guys look at you, oh, that's a bunch of dirt. But in science, we call it sediment. All right, now to get from sediment to sedimentary rock, we need to obviously rockify it, right? So we've got that wonderful word there, lithification. You should know the word lithification. It's also, you may have heard lithify, right? But again, it doesn't mean a whole hell of a lot. Lith means rock. And ification is kind of like Latin English for turns to. So turns to rock. That's about as helpful as solidification is. In this case, we're gonna change the word there. You can leave it again. It's okay. But at the very least, underneath it, write compaction and cementation. Compaction and cementation. And that's in cementing, not the other word that it sounds like. So we squeeze it and we glue it. So sediment sitting around at the surface gets compacted. Over time, it gets filled up with some cement. We'll tell you how that happens too. I know you can't wait. And it gets turned into something called sedimentary rock. Then from sedimentary rock to get to metamorphic rock, we need to go through the process of metamorphism. Great, okay, again, it's a nice word. What does it actually mean? What it means is exposure to high temperatures and or pressures. We've got to have an and or in there. Because you could have one, but you don't necessarily have to have the other. It doesn't work vice versa either. So you can get the temperatures without the high pressures, but if you have the high pressures, you're definitely going to have those temperatures. And that turns it into a metamorphic rock. And then metamorphic rock, the next stop on this clock is back to magma or lava. Now this, of course, is why they only use the word magma here, because in order for this metamorphic rock to happen, you're deep down inside the earth. And what do we call that molten rock material inside the earth? Of course, we call it magma. Lava is what it is at the surface. So again, that's why they only have the word magma here, but we're altering this for our purposes. So that metamorphic rock goes back to magma or lava, and we have the word partial melting there. We're just going to change that to remelt. Remelt. There's a fine line, especially when you get pretty high into metamorphism. You're essentially, just dealing with a water balloon of a rock there. It has its outer skin, but the whole inside is just a mess. And at some point you cross that line and it just goes back into melt. You can't burn a rock, but you certainly can if you get high enough temperatures and pressures. You certainly can melt one. So we're back to the beginning here with magma or lava, which cools and crystallizes into igneous rock. That igneous rock works its way to the surface, where it's exposed to weathering and erosion, produces and transports sediment. That sediment gets compacted and cemented together into sedimentary rock. That sedimentary rock gets dragged back down into the earth, exposed to high temperatures and or pressures, where it becomes a metamorphic rock. That metamorphic rock stays down there too long, it will remelt into magma. Now, if you could utter those 6 sentences in 3 weeks or so, you'll be able to handle any multiple choice diagram, whatever you want to call that matching diagram thing that I can throw at you. Okay? If you try to memorize this as a diagram, you'll probably do all right. But read it as a sentence, and you'll get a much better grasp of what's going on here. Now, what are these other arrows about? Well, there's one on the bottom we're not even going to worry about. That's for a higher level class. So the rock and mantle and that arrow coming up, that's just telling you that this can get refilled every so often. That's cool, it's great, but we're not going to worry about that at all. We do want to worry about the spaghetti bowl of arrows in the middle, though. And I'm going to reorient a few of these, which is, again, why I asked you, don't draw ahead. So let's go back up to igneous rock here. That rock coming out of igneous rock and going down to metamorphic rock is because not all rocks make it to the surface where they get broken down by weathering and erosion. Some rocks stay deep inside the earth and undergo the processes of exposure to high temperature and high pressure and turn into a metamorphic rock. And as such, I think we should draw that arrow to the word metamorphism, not to metamorphic rock, right? Makes sense, because you got to go to the process and then to the product. The rectangles represent products. The arrows represent the processes. So not all igneous rocks break down. Some of them turn into metamorphic rock. Okay. While we're down there, let's talk about metamorphic rock. Not all metamorphic rocks remelt, right? Some of them work their way to the surface where they get exposed to weathering and erosion, turn into sediment, blah, 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 blah. So again, let's move that arrow over just a skosh and have it point to weathering and erosion instead of the word sediment. Still true, just a little truer. And while we're at it, the simple fact that we're going to walk into the lab room and look at igneous rocks, look at metamorphic rocks, look at sedimentary rocks, this diagram is missing at least 3 arrows. You don't need to draw them, but think about it. There's always an arrow going out of said cycle, and that's you walking along through the woods or along the shore saying, ooh, cool rock. You stick it in your pocket, you set it on your shelf for 30 years. Lord knows there's plenty in the Jocko household. And I'm sure some of you as well. So, or sitting in the lab room or whatever. All right, that's out of the system. Let's see, we did the metamorphic rock arrow, we did the igneous rock arrow. Oh, we got the sedimentary rock arrow. This little tiny arrow over here, which, by the way, if you couldn't predict, I want you to point to weathering and erosion, not to sediment. But sedimentary rock to weathering and erosion to sediment to sedimentary rock to weathering and erosion. It's a rather small little loop there, but it is by far probably the most, it's constantly going on. It's not horribly exciting to be a rock, if you hadn't guessed. And that's where the majority of the rocks at the Earth's surface, they just keep getting in that loop over and over and over again. And going back conversationally, we talked about, why it's so hard to find a really, 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 really old rock, okay? It's because the stuff that is here has been broken down so many times. And, each time they get to smaller and smaller pieces and more dispersed, spread out. So that's the rock cycle. Any questions about that? I'm not going to have you draw it, but you will definitely need to label it. Well, no, because it's matching, and that will totally mess up confuse the computer. I need you to put igneous rock at 11 o'clock. Yeah, please. Good question. I think I leave a few in there as placeholders, so you don't make that mistake. I mean, I still have people try it, don't get me wrong, but yeah, no, it definitely, it is a cycle, it is a circle. I just meant conversationally we would have started anywhere. Yeah, but in the beginning there was magma, so I mean that is really the beginning. But yeah, I'm almost positive there's a placeholder too. Like I might have left the word sediment in there, and you just know you got to go so many clicks back from sediment to get to the things. Great question. What else? Okay. All right. So changing gears a little bit to some more rock stuff. If I could get it to change slides. So we've got geologists all over the planet, and back in the day, everyone that was anyone in science, they had a common language or two, Latin and a little bit of Greek, and that helped because you could read anybody's papers. Read anybody's books if you knew the secret language, right? Nowadays, really, I don't say paleontology is the only place where we still use that, but the naming of critters and plants is still mired in that. But everything else, we use our common words, whatever our native language happens to be. And while a lot of folks do know English on the planet, not everybody does. So one of the ways they figured out long ago was the use of symbols and colors, but primarily symbols. And how they agreed, again, back before the days of the internet and, and we had just telegraphs and whatnot, how they agreed on what symbols meant what, I don't know, but they did at some point. And they're fairly common sense, as you'll see here. Again, you don't know a whole lot of these rocks yet. We're going to use a handful of these, primarily because we often get to talking about groundwater in here. Not every semester, but most semesters. And when we talk about groundwater, we have to draw some rock layers. And when you're drawing those rock layers, you know, the reason you're drawing them is to talk about the rocks that are down there. And we will put these symbols in said rocks, so you know what kind of aquifer and so on and so forth you were working with. So I want you guys to recognize a handful of these. My lovely scribble. But again, much closer to what you would see on a test than that nice table before us. I just have you guys recognize 4 symbols. The bricks there are limestone. And once we've gone through this and you learn to start recognizing limestone in the wild, you may understand why they use bricks for limestone. It tends to break into these little blocks. If you're driving down, cover your lab book. If you're driving down the thruway and you drive past the little falls exit and all that beautiful, what is that giant cliffs of black rock there? Yes. Now, there's a little bit of limestone there, hence my story. It's shale, all right? All those black cliffs are shale. Nestled in there are these creamish gray layers, all right? And next time, this weekend maybe, just take a little road trip, drive down there and look, as long as the ice flows aren't back. The ice flows are probably back, which are beautiful too. But you'll see these little creamish gray layers every so often, and they are blocky. They look like bricks. So we draw limestone as bricks. Letter B there. Those are supposed to just be a whole bunch of little dots. Okay, I can only draw dots so long I get bored and they start to get a little less dotty at some point. Those are supposed to be little teeny tiny grains. Well, what kind of rock is made up of little teeny tiny grains? We're going for sandstone there. Okay. Number C there, the dashes look like tire marks or whatever. That's our shale. And again, if you're familiar with shale, you know shale's a whole lot of thin layers. It's all broken up and everything. So it makes sense. And then lastly, D, those little asterisks there, those little stars, those are supposed to be crystals. And that is just a generic for igneous rock. We're not breaking it down into what kind of igneous rock, basalt or granite, or we don't care. Somebody out there does care, and like you saw, there was a whole bunch of more symbols on that other sheet. We just need a generic igneous rock symbol. Because again, when we're dealing with groundwater, we really just, we want to know that igneous rock is there, okay, because that's a great base layer. That's a great seal. But we don't care, like I said, what kind of rock it is. So these other 3, those are sedimentary rocks, and we've got very specific symbols for each of them. Because we care. We care whether your water is in limestone or whether your water is in sandstone or shale. So anyhow, I just picked 4 because they're very useful in some very common drawings. I guess I did put some pictures in here. This is a little diagonal here, but you see the sort of the blocky nature there in the limestone. Great example here and here. And while it's not as uniform as a little brick wall that you might spray paint Pink Floyd on or something like that, but it is certainly, you get the idea where they can see that. There's your shale, depending on the resolution. Whoops. Of the screen, you can't quite tell. Up here you can see a lot of that layering. Sandstone, again, the little grains of sand. And look, I went and took a picture for you. So, again, you see that tannish stuff there at the bottom. That is our limestone there nestled in amongst the shale. And I do this for a very good reason. In geology, we go a good bit further into this than we do in earth sciences. We're going to talk about transgressions and regressions of the ocean over the years. And these are, wherever you see limestone, that tells you there was an ocean there. Limestone only forms in saltwater and marine water, marine environment. And we also know from studying them that shale and limestone form at different depths. So while we see, this one cliff face right here in Little Falls, New York, okay, what that's telling us is that over however much time that represented, that water depth changed that many times, and from that shallow or that deep. I'm not going to start throwing numbers at you. Heck, I'm going to throw numbers at you when we officially talk about this. But that's why we just sort of shake our heads when people yell about ocean levels changing and so on and so forth, as if it can't happen. It did happen. And if it did happen, there's absolutely no reason it can't happen again. I mean, I guess you can move the continent out into the ocean and drag it back out of the ocean several times, but it's a lot easier to just have the ocean get fuller of water, or have all that ocean water go into ice, which would remove it and lower the sea level. So, like I said, it's just, you can't argue with some people, but we know that sea level has come and gone several times. In that, right here in the middle of New York, I mean, we have coral fossils here. There was obviously an ocean. So, anywho, so since shale and limestone is a very common series and a very sort of educational series as well. And like I said, we will talk about it when we get to another chapter here in geology. All right, and from here, as I said, we go off onto, in geology, we go off into a number of different chapters. We've got igneous rocks, volcanoes, sedimentary rocks, weathering and erosion, that stratigraphy that I just kind of mentioned about this stuff, that's the layer, talking about layers, and metamorphism. For geology, this chapter opens up, this conversation today opens up the next, 2 months of conversations, and spanning a test and a half or so. In earth science, it's just the beginning of a geology unit for you guys. From here, we're going to go and talk about volcanoes and earthquakes and plate tectonics. So we're just hitting some highlights there for you folks in earth science. But in geology, obviously it's one aspect of earth science. So we're going to get into the nitty-gritty a bit more.